All right, so 739. We actually already went over. Which one was it? We went over 17 in one of the video conferences. So those have been posted on Microsoft Teams. So if you got a question on that one, it's in there. All right. So 739. Here we basically had 20 volt source, 4 ohms, 2 farads, 1 ohm resistor right here, and then the switch was on the side. And that switch opens at t equals 0. So first thing we need to do, obviously, is find that voltage across the capacitor, that initial voltage. So t less than 0, basically 20 volts, basically drove energy to that capacitor, but we also see that that cap was in parallel with the 1 ohm resistor. And so basically we found that the initial voltage was dependent upon what was built across that 1 ohm resistor. Now, even though this is an open circuit right here, and all current would just flow right through that 1 ohm resistor right now, that cap is still there, guys. And I want to make sure everybody understands that even though we model the cap or the inductor, either by an open circuit or respectively as a short circuit, they're still there within the circuit. Now, here, V naught, that's just equal simple series loop by that cap acting like an open circuit. Got 20 volts multiplied by 1 over 4 plus 1. Here we go, 4 volts. All right. This one's a little bit tricky for some of you guys, especially if you're not in the lab and you don't get to see this. But for t equals infinity, basically at t equals 0, that switch had opened, and then basically that 1 ohm resistor is fully disconnected. It's not even in play anymore, guys. And so sure enough, we get 20 volts, and then that cap is still connected to that 20 volt source, even though it's acting like an open circuit at t is equal to infinity. And that 4 ohms is right there, but because that cap is acting like an open circuit, no current's flowing within that circuit at all. It's not at all. But even though no current's flowing, that 4 ohm resistor still allows the ability for that cap to be connected to that 20 volt source. And due to that notion, the only voltage that's going to be applied across V infinity is going to be 20 volts. That 4 ohm resistor doesn't have voltage applied across it because no current's flowing through it. No current's flowing through it, no work is being done. So sure enough, 20 volts actually becomes what we would see as a final condition for the capacitor voltage. So for t greater than 0, we're looking for tau. So tau is equal to R Thevenin times C. So the only thing we have, we turn off that voltage source, and that causes the 4 ohm resistor to become in parallel with our capacitor. And sure enough, we get V of t is equal to V infinity plus V naught minus V infinity for the coefficient of our exponential. Total response comes out to be 20 minus 16 times e to the negative t divided by 8. Okay, 8 being our tau, our time constant. 8 seconds is a lot, but 4 ohms and 2 farads is a lot of time. All right, got some more problems coming up. See you in just a bit.